All right, so let's try the first cryptography project here. There's a bunch of them, but the first one's one to get started with. Cryptography, like everything else, is pretty easy in Python because there are libraries to do all the work for you. Now, as you may know, Microsoft Windows, if you have two users with the same password, it stores them with the same hash. Now, old operating systems like I think perhaps MS-DOS would actually store the password in plain text on the disk, but people rapidly figured out that was a bad idea, so they'd store it as a hash. And this is the hash of the word password in Windows, 8846 and this other junk. So we can calculate them in Python by using the hash library. So let's do this. Clear and nano hash1. All right, this imports the hash library, and the Microsoft hash algorithm is MD4 because they invented it in 1993, which is so old that MD5 had not been written yet, much less SHA-1 and SHA-2 and all that. So this is the system they used. So I have the literal word password encoded as bytes and then hashed with MD4. So if I run this, it's going to print the result of the hash library, hashing it, Python 3 hash. I got to spell Python better. All right, so it printed, but the result is the address of a hash object, not the actual hash. So it did it, but it didn't print the answer. What I really wanted was the hex digest, which is the familiar answer that we want to see. So let's get my code. All right, and I really want h.hex digest, hex digest. All right, let's run that one. All right, now I get a hash. The only problem is it's wrong. The real Windows hash is 8846, and this is 8A9D, because there's another wrinkle. Microsoft, even in 1993, was an international operating system selling through foreign languages, so the hash is not calculated on the ASCII encoding of the word. It's calculated on a really old version of Unicode, which is what was available, I guess, at the time. What Microsoft chose was this 16LE version of Unicode that uses 16 bits for every character, which turned out to be a really bad thing because it doubles the size of every string for normal English, and it's not really enough bits to encode all the international languages. But that is the standard of Windows, is these 16-bit Unicode characters. So let's do this one, which is going to be hash2. This is going to take the word password and encode it with this UTF-16LE. And now, if I run that one, I finally get the 8846, which is the correct Windows password hash. So that's how you get password hashes. And now you can calculate 100 of them from 00 to 99 for all 2-digit pins, and you'll find a flag. And you can crack some password hashes. These are real Windows hashes I extracted from Windows 7 machine with the hacking tool Kane. So the username is here. These are, this AAD thing is from an older hash algorithm that is so bad even Microsoft won't use it anymore. So that's always just an empty placeholder. This is the actual NTLM hash, the last bit. So you can crack these passwords, and then you can crack other kinds of passwords, MD5 with several rounds, and MD5 and SHA-1 with many rounds where you don't even know the number of rounds. All these are pretty easy to do because these hash algorithms are extremely fast. And then you can crack Linux password hashes, which are literally 1,000,000 times stronger than Windows password hashes. You can do that with the crypt library and crack some of them. So and then there's LastPass. LastPass, your master password, is actually encrypted with 100,000 rounds of SHA-256. You do so many rounds, hashing the hash over and over, just to make it very burdensome to calculate a hash, so that if you have a dictionary of 1,000,000 passwords, it would take a very long time to calculate all those hashes to crack it. So there are some other ones here. So there's quite a few hashes to do. And that's the start of cryptography. And there's many other things you can do, the Caesar cipher, XOR, and many other things available, but I don't think we'll get to them here. And you can even do machine learning and quantum computing and server-side templates with Python, but I think that's all farther than we're going to get in this class. So that's a little bit of cryptography to get you started. I'm going to